dear learner, welcome back to our lessons. As usual, Wilfred Momanyi Onkangi-Kiongozi is my YouTube channel. Continue subscribing, sharing everything and liking everything there, and we shall learn together. This is a weekend of mathematics, and I'm so glad you're still following me. And today I have a very interesting chapter, a very interesting subtract, laws of indices. I thought of doing this because I know there are questions that come in paper 1, and you may lose a few marks without your information. I will give you a few laws, like 4 of them, and then of course give you 2 examples to support the laws. This is a very, very easy chapter. You get very easy questions from the same, and I hope you are going to concentrate. Let us look at the 4 laws that I have for you. The laws. The first one, before I say that, if you have a notation where A is raised to power M, this A becomes the base and M is the power. If they are many, they are called powers, and that is where the term indices is derived from. Indices means when it is 1, it is an index. That's the first thing you need to understand. And then of course, we have the laws now. The first one is A power M times A power N. In this case, the bases are the same. Then we shall have this common base. Then because it's a multiplication here, then we shall add the powers. The powers are added. If it is a division, A power M divided by A power N, then we shall have a common base, then M minus N. We have another one, we have one. A power M raised to another power, say N. In this case, we multiply the powers, and then the powers will form a product. So the base and M times N, which is Mn. We have the last one, the inverse one. This one is called the inverse or the reciprocal one. So in this case, what we do, if we have A raised to -1, this one is equivalent to 1 over the reciprocal or the inverse A raised to power 1. That means when this one comes to the denominator of that power, then the negative sign disappears. For example, if you have A power -3, this can be written as 1 over A power 3 without a negative sign. These are some of the laws I want us to apply and do 2 examples. We move, but before we go there again, I have remembered that there is need to incorporate the prime factorization concept. In this case, when you have large numbers, for example, you have 16. This number, you will write it in prime form so that you get the prime factors. This one can be written as 2 times 8, which is the same as 2 times 8 divided by 2 is 4, which is the same as 2 times 4 is like 2 times another 2. In other words, 16 is going to be 2 raised to power 4. You have done what we call prime factorization. Example 1. Find the value of x. Example 1. Find the value of x if bracket 1 over 8 raised to 2x minus 9 is equals to 4 raised to -3 over 2x. Solution. So in this case, first of all, let us do prime factorization of 8 and 4. The prime factors of 8 can be written as 2 times 4, and also be written as 2 times 2 times 2. So 8 is equivalent to 2 power 3. 2 power 3. 9 is the same as 3 times 3, sorry, 4 is the same as 2 times 2. So it is written as 2 power 2. These two are the most important factors we are going to substitute in these big values here. So we have 1 over the prime factors of 8, 2 power 3. Close the brackets, 2x minus 9 is equals to 4 is the same as 2 power 2. Then of course brackets, negative 3 over 2x. Now let us do the inverse of the first one here so that the common bases are on the same level. Note one is in the denominator, the other one is in the numerator. So we shall have 2 power negative 3. Remember our last law, when 2 power 3 goes to the numerator, a negative is introduced to that power. Then multiply by 2x minus 9 is equals to 2. Powers are multiplied here. So we have negative 3x. So in this case, open the bracket here. These are two values multiplied by one value. So we shall have 2 negative 3 times 2x is negative 6x. Then plus, negative 3 times negative 9 is plus 27 is equals to 2 raised to negative 3x. Now, similar bases or common bases are dropped, not cancelled. So you drop the bases, then you take the powers. Take the powers. So we have the powers, negative 6x plus 27 is equal to negative 3x. Then we bring the like terms together. Let us take negative 6x to the other side of the equal side. So we shall have 27 is equals to negative 3. It's a minus here. It will be a positive on this other end. So it will be 27 is equals to 6x minus 3x is 3x. Divide by 3 on both sides. Divide by 3 on both sides. The value of x is 9. Those are the important steps you need to follow. Prime factorization. This one of the reciprocal, it has a mark. And then of course, taking up the powers and dropping the bases because they are common. And that is what you get. Example 2. Example 2, solve for x. Solve for x in the equation. The equation is given below. 3 power 2x raised to power 3 is equals to 81 times 9 raised to power 4. Solution. The first thing is to prime factorize these two numbers. 81 is the same as 3 times 3 times 3 times 3. So this is like 9 times 9. So 81 is the same as 3 power 4. It's very important. Then 9 is the same as 3 times 3, which can be written as 3 power 2. So these two are the most important factors that we're going to substitute in these big values here. On the left-hand side, and of course we have the right-hand side, this is what we shall do. In this case, we shall multiply the powers. That is the law I gave you. I think law number 3. So we shall have 2x times 3 is 6x, which is equals to left-hand side, 3 power 4, which is 81, 3 power 4 multiplied by 3 power 2. 3 power 2. But remember, there was this 4 before we factorized 9. And that is what we place there. So that again, we multiply 2 times that 4. We have 6x is equals to 3 power 4 times 3 power 8. In this case now, common bases on the right hand side are put together. So we have 3 power 6x is equals to 3 power. This is a multiplication, so we shall add the powers. That gives us 4 plus 8 which is 12. At this juncture, we left with similar bases. Drop common bases. Drop common bases and take powers. Take the powers. You get that? So we have 6x is equals to 12. Then if you want the value of x, you divide by 6 on both sides. Divide by 6 on both sides, and your x is equals by 6 1 by 6 2. Your x is 2. Again, common and very important things: prime factorization, forming similar bases, and then of course at a point where they are now common, you drop them and take the powers. That is our last example in this video, and I hope you shall join us in the next video, which is a little bit more complex. See you.